Hello friends, we are going to talk about solving linear differential equations and I'm going to prove to you why this method I'm going to tell you works. So what we're going to want to do is we're going to want to solve this guy, dy dx plus the function p of x times y equals the function q of x. All right, and the way we're going to do this is we are going to multiply on both sides by a positive function v of x. And we're going to talk about how to choose v of x later. But we're going to multiply by v, and what that's going to do is that's going to transform what we're looking at to the derivative of this product. And when we think about a derivative of a product, we have our product rule. So first times the derivative of the second plus second times the derivative of the first. So let me slide this up and we're going to talk about a little bit why this works. Which is going to be my proof here. So if I took that function that I had up above, dy dx plus p of x times y equals q. And I took the whole thing and I multiply it by some v of x. Well, now what I have is v of x dy dx plus p of x v of x times y equals v of x times q of x. And so what this is right here, this left half is kind of the reverse of a product rule. And so what the product rule is, so we have first derivative of the second, and then all of this represents the derivative of the first, okay? And the reason this works is essentially we've chosen this magic v, and we pick it in a way that it will work, right? So v is chosen, so this works. And again, we'll talk about how we pick that v in a little bit. So if I take what I'm looking at and I rearrange it a little bit, so if we want to think about this in a condensed form, we could write this as v times y prime plus pv times y, right? And that's my product rule. So essentially what that's telling me is that this is equal to the derivative with respect to x of v times y. So understanding that that's the reverse of the product rule, I can take what I had up above and now I can just say that d dx of v times y equals v of x times q of x. At this step, we can integrate both sides, and integrating both sides on the left would cancel that derivative because they're inverse operations, and then I end up with the integral of v of x times q of x dx. And if I were to try and isolate my y value, that is y equals now 1 over that v times the integral of v of x times q of x dx. And so that v we were talking about on the left. I kind of left it out of my notation, but remember, v is a function of x, so this is really what we end up with here, 1 over that function v of x. And so this v, now that we're talking about v of x, is what we call the integrating factor. And the presence of that v of x is what makes the function integrable. And so that v is chosen specially to make it work. All right, so v of x is what makes it so that we can integrate. So you may be saying, why is p of x not in the solution as well? However, it is indirectly in the solution. Indirectly, it is the condition imposed on v. So let's look at what we had previously. We had d dx of v times y equals v dy dx plus pv times y. So this is how we set up our product rule. So if we think about the derivative of a product, that would be first times the derivative of the second plus second times the derivative of the first. So v dy dx plus y dv dx. And so what we're saying is that this is equal. So what that means is that this must equal that. Or rather, we can say y dv dx is equal to y times pv. And so this will hold as long as we have some conditions met. So if dv dx is pv, then dv over v equals p dx. I just divided and multiplied. Integrating both sides, the integral of 1 over v dv equals the integral of p dx. The integral of 1 over v, that is ln v, equals the integral of p dx. And then we can simplify this and isolate that v value if we exponentiate both sides. So this is the same. I can say e to the ln v equals e to the integral of p dx. And then, of course, we know this exponentiation cancels, and so the way we always will define v is going to be e to the integral of p dx. Or more formally, we'll say v of x equals e to the integral of p of x dx. And so we're going to use this when we're dealing with these differential equations in this section. So what we're going to want to remember is to solve the linear equation y prime plus p of x y equals q. If we've got it into that standard form, we're going to multiply both sides by the integrating factor, which is v of x. V of x is always going to be defined as e raised to the power of p of x dx. The integral of p of x dx is in the argument. And then at that point, once we're done with that, we can just integrate both sides. Using this procedure, you're always going to obtain or put your v of x times y on the left, which is the product of the integrating factor and the solution y. And that's always going to be on the left side.